Well, I want to welcome everyone back, particularly the students in the SPE section at the Pandit Deen Dayal Petroleum University. My name is Jim Crompton. I'm a professor of practice in the Petroleum Engineering Department at Colorado School of Mines in Golden, Colorado, in the United States. And I'm coming to you virtually via this recorded video, or maybe video blog if you want to use that kind of more modern term. And I'm talking to you about the digital transformation of the oil and gas industry, version 2.0. And in the first part of my lecture, I focused a lot on the hope and the hype of this digital transformation, or so often called the digital oil field 2.0. And so in this section, I'm going to focus a little bit more on the current reality and the challenges ahead. Well, the current reality is, the industry really is making progress. There are a number of digital oilfield 2.0 use case examples that I'm going to share with you. And, in a number of different ways, drilling in particular that we talked about a little bit in terms of the productivity section, we've been able to do better with the data that we're collecting, make better decisions, improve the efficiency of our operations. And so, there's hope, and there's even greater expectations as more companies are taking a look at this stuff, and and more solutions are coming out for the industry to use. But the main thing we really need to think about in terms of the analytics in version 2.0 is that this analytics that we're really trying to chase is inherently multidisciplinary. I mean, the domain experts are still needed. This, as a petroleum engineer, whether your expertise or knowledge or experience is in drilling or in completions or production or even reservoir, for the other kind of very important elements of the earth science, whether in geology or geophysics, this domain knowledge is very important and needs to be sitting at the table with your new analytics teams. Joining that group that's been there for a while are the new group of math and statistics knowledge. These are your data scientists, your statisticians, operations research professionals, etc., bringing their math related kind of skill sets and tools to all of the new data that we've been collecting. But because of how we have managed data over the years, we still need people who will know where the best data is, and we know how to do manipulation and normalization of large amounts of data and a large variety of data as well. So those with the data handling skills are also important as part of this team. So you'll see many companies now, they don't just have a single individual who is knowledgeable in all of these kind of areas. They really are forming teams. And they're forming teams of their traditional domain knowledge experts, the new data scientists, statisticians coming into that, and pulling people from their data management organizations to help, with the productivity of managing this large amount of data. Well, and really the challenges also from 2.0 are a little bit differently. If you look at kind of analytics in a kind of an evolutionary sort of sense, originally we were just trying to figure out what has happened. And that was done largely within a silo. I mean, the drillers wanted to know what a drilling incident happened to be. Was there stuck pipe, lost circulation, or a bit wearing out, or whatever, that kind of situation. The production engineers were looking at a higher water cut, or production climb that was faster than expected. And the operational maintenance people were worried about how long critical equipment was going to last until the next maintenance job that needs to be done. But now we're working on we're moving up this curve. I mean, from the what has happened, and we're wanting to know why did an incident happen? Why was a production, forecast missed? Why was the drilling, take longer than we had expected on our drilling plan? So from the what has happened and now to the why has happened, and that was really kind of digital oilfield 1.0. Now we are pushing the realm towards the future, the forecast, the simulation sort of thing. So now management is asking us what's likely to happen. forecast current performance and tell me what's going to happen in 3 to 6 months or a year from now, or what's going to happen if I drill well number 1, what's going to happen by the time I get to well number 6 or 7 within the program. And they're not going to stop there. I mean, the full optimization question is really going to be how to make it happen better. Not just with our uncertainty and our probability statistics say this is 50% of the time it'll be, at this, maybe better or worse. But how do I improve my probability of something operating in a much better fashion? So in 2.0, we're becoming more multidisciplinary, and we're also becoming more future-oriented. So with this, the role of analytics continues to grow and gets better and more important part of our process, more critical to the work we're doing. Well, this is kind of another way of describing that multidisciplinary team. And it really has to do with this Tshape Expertise. And what I'm really kind of suggesting here is, and this is particularly true for, students, as they are completing their education. You may complete your degree, you're never going to finish learning. That's kind of the point number one I would always make to students. But in a sense, while a lot of traditional curriculum will help you become more expert, the deeper part of your expertise, if you will, in the particular domain that you have chosen, you also need to be aware of the need to broaden your expertise. If you're a driller, you need to understand how a well needs to be turned over to the completions crew. If you're a completions engineer, how is it going to be turned over to production? If you're in production, how does it impact the reservoir? And all of this, I talked about before, the importance of economics. So, the goal is profitability, not volumes. So, how have all of the energy and the effort and the investment we're putting in, are we getting our money back? And then also now with so much digital enabling technology around us, we all need to become a little bit more digital literate and grow our understanding of the IT environment that's around it, from sensors to communications to processing algorithms. And then even, most of us will end up, programming a little bit in order to build our models. Well, with all of this, there's a lot of people just asking the questions, are algorithms taking over the world? And my short answer is yes, they are. I mean, there's so many different ways and so many areas where we can take all of this data, and there's just far too much for human beings to work on. We've broken Excel because we have so much more data that even, that very important and useful tool is becoming, more limited in what we were able to try to talk about, which is why there's the growth of the statistical programming languages like Python and R, and the ability to handle a lot more data, a lot more diverse kinds of data, and essentially build these models, data-driven models, so hopefully with also the physics constraints, and build these models so that we can forecast the future. All of that kind of comes together. And in that, algorithms are becoming a more and more important part. I heard one university professor was talking about how all their intellectual property was being now encoded and delivered in software. Well, with software, and now you put, a natural language interface to that, and we're talking to our technology and our kind of daily lives. Isn't long before we'll be talking to our technology in the oil field. So AI, artificial intelligence, is moving from just a tool. It's now becoming a coworker. And that is either a very exciting prospect to some. It's also a very scary prospect for others. Well, I said I was going to talk about some use cases within this, kind of section. And, for drilling, there's nothing more, important these days than directional drilling. Most of the wells in the North American shale plays are clearly now involved in long laterals. You may drill 10,000 feet to your vertically to your location, but then you may end up going out, 10,000 feet or more in terms of a lateral. So this directional drilling, is not new. I mean, the first known multilateral well was drilled in Russia in 1953. So they've got a lot of experience and a lot of wells that have been, drilled this way. And even that the idea of the extra cost of the lateral has proven itself economic in a lot of cases because of the amount of greater production that you can kind of had it. And this well, there was 17 times more oil than the offset well, with a cost of only about 50% more. Well, so if you look at that way, this is an economic adventure, even though the drilling costs go up. But it was that kind of technology was sitting around for almost 40 years before it wasn't until 1993 in the modern era of multilateral technology began. But this also involves a lot of data. And you have a directional driller sitting there. He may, be trying to stay within maybe a 30-foot geologic zone with a little bit of ups and downs, or, worrying about a fault or two as it goes along the line. But he's trying to do that for nearly 2 miles. So the idea of all of this information from the measurement while drilling, kind of information coming back to them, they're really artists and data driven in terms of the solution they're trying to do. And now when you take a look at the communication aspects, the connectivity, there's one major operator that's drilling all of their directional wells from a single center in Houston, kind of no matter where the well is in the world. So you could be able to put all this stuff together, and you can see directional drilling from the driller's perspective is really an amazing, one of these digital enabled solutions. Well, the other part of all of this is by understanding how we are drilling and what, where is the non-productive time? Where's the invisible lost time? How productive are we in a rig moving, what's called the drilling learning curve? Can we drill well 2 faster than well 1? Can we drill well 6 better than we drilled well 2? And essentially, we're being able to reduce the cost in terms of drilling days, in terms of overall expense. And so the drilling, community has been able to, again, as I showed before, drill a lot more wells with fewer rigs over a year, drill them faster, drill them more efficiently, and then, set this up for the large production increase that comes from all of that. So the advantages in the unconventional from all of this, this information that we are collecting and the new insights that we have as rapid, low-cost experimentation. And across multiple operators, multiple drilling companies, and because there's a lot more data to analyze, it's coming in faster. This is a real velocity and variety and volume problem. And essentially, even small gains add up over large drilling programs. Well, as I said before, we're able to take this data from wherever we are drilling, very remote locations, to infield drilling, and we can bring it back to a central location. And originally just for monitoring and surveillance, but then we can do more with this. The concept of came from the Digital Oil Field 1.0. It's called managed by exception. Can we compare our actual performance to what we predicted, what our model said it was going to be? Can we take all of that information and then maybe make interventions, change our drilling plans or our production plans in order to improve performance? All of this data with the visualization capabilities that we now have, there are rooms all over the place with just, whole walls full of screens like this. And we can not only see what's going on versus our model, we can benchmark one rig against another. And essentially we can really do an awful lot with the data that we are collecting. Well, it's kind of interesting that we're now, when we say we're looking for patterns, and maybe the first thing that would come to your mind would be, a production decline curve or drilling, sort of time curve and observations of performance versus time and cost. And clearly that is probably number one as we go through this. Well, we're also beginning to look for other patterns. And here, when you look at the performance of a rotating artificial lift pumping unit, essentially our pattern is a lot different looking, right? And the kind of information that we get from the sensors on the pumping unit is still give us an idea of what is a good performance, i.e., the pump is the rod pump is performing, and we are lifting fluids to the surface, versus what other kinds of problems that you can have. Just like in drilling, we can bring a lot of information to look for the performance on bit wear or, stuck pipe problems, taking kicks, et cetera. Now we can look at the good performance of critical equipment like a pump or a compressor, or kind of the engines on the rotating equipment, and essentially we can tell when equipment's wearing out or parts of the equipment are wearing out or not performing, kind of up to top expectations. And through this, we can go from kind of reactive maintenance or run to failure maintenance, or operate according to the original equipment manufacturer specs. But we can get to do predictive maintenance. Again, that idea of forecasting performance into the future and then being able to figure out actions that we can take in order to keep performance at the highest possible level. Well, we're moving into this kind of idea here of using artificial intelligence, data-driven models to even prove the performance of artificial lift. And here, one, international operator, Equinor, has been, partnered with an artificial AI company called Ambient, and the data that they're trying to optimize is essentially the sensor data coming off of a pumping unit. And originally, when they built the baseline sort of models, they found out just how inefficient, the process was. So with all of this, they now can build the model. We can go across and we can figure out what are the units, the time cycles, the pumps, the speeds, etc. And we can dramatically improve the performance of the pumping operations, which means we can lift more fluid with less energy. And that is a productivity in terms of cost. So this sort of AI-powered artificial lift optimization is now being used for a lot of different sorts of equipment. Again, we talked about rotating equipment and compressors and pumps, etc. And we can build a mathematical model of that pumping unit. Maybe it's difficult to do that from a physics-based process, but we certainly can do it from a database process, neural nets and other sort of techniques. And then essentially we can improve the performance of this information from the data we're already collecting. And the communications channels may be through Internet of Things devices on the edge, or it may be through cloud or mobile computing sort of connectivity. And we can take this data to wherever the experts are, and we can bring suggestions and guidance and recommendations back to the field on how to improve performance. Well, you continue along this trend, and all of a sudden you get to the fact where you can begin remote operations. And here, a field in the Norwegian continental shelf, a field called Valemon, was the first platform in Statoil, now Equinor's portfolio, to be remotely controlled from land. So essentially, you take the control function, the controlled room and decks, off of the offshore platform and bring them onshore. And that's where the human beings will operate. And essentially, you may have a small staff, still in your remote location doing maintenance work or small project work or whatever. But essentially now we've moved the control function, not just monitoring surveillance, the second pair of eyes, but actually even the control function onshore to the offshore operations. And, we can then kind of operate, in this way where maybe human beings are in a safer location, taking humans out of harm's way, if you will, and being able to build that closer with our high performance computing where our models are being generated, and be able to operate in a very, very different kind of way. Well, we keep adding new data sources. And here, that one of the very interesting things that are happening is the use of drones for inspection. So essentially, another pair of human eyes. And they could be airborne or they could be subsea. But we're being able to, to put these packages, and they can fly either controlled, sort of patterns, or even autonomous sort of directions where they're kind of sensing where the interesting data or the actions need to be, and they will, kind of adjust their course and their program, based on that data-driven effort. But we are, again, we're augmenting the human role on the oil field sites with this sort of technology. And it is, again, bringing us maybe more efficient ways of doing things, safer ways of doing things, and we're being able to have a much more holistic surveillance, now digital this way, of what all is going on within the operations. I've talked about some of the promise, and I've talked about some of the applications that are creating value today. But this isn't all easy. And you always have to remember the people, process, technology sort of mantra, and being able to have solutions that work for all of three of these things. And there's some other important issues such as data and the organizational cultures that we have in our companies, and are they ready for this digital transformation? If they're not, we're probably going to slow down the progress that we thought we were going to have. Well, let's just for one short of example, let's return to our shale drilling sort of operations. And we know we're able to drill a lot of wells, and many of them pretty close together, in a single sort of well pad. And this in particularly in North America, but potentially expanding to many other shale basins in the world. This has really led to a dramatic increase in the amount of oil and gas that's being produced. But this shale process isn't all good news. There's no question that we're drilling more wells faster and cheaper. We're drilling these directional wells, these multilaterals. We're fracking them with a lot more intensity, and so essentially we're driving production up. But there are some important challenges that, particularly with lower oil prices, that this unconventional industry is facing. So the challenges in shale aren't so much about volume growth. It's about efficiencies. It's about logistics. So when you think about onshore production, you're having to bring in, dozens and dozens of truckloads of equipment on site in order to do particularly the completions aspect of the well. We're using this energy, so we're increasing water use. In some of these areas, water is a scarce commodity. Our ultimate recovery is still pretty low, particularly versus conventional sort of reservoirs, because really all we're really doing is creating fractures and then draining the fractures, and then after that it becomes a very difficult challenge. We're trying to understand the sweet spots in the reservoir. The rocks still have a vote in how well our operations go. We have to worry in our fracking operations, or even more so in our water disposal, saltwater disposal operations, that we're not creating our own set of problems such as induced seismicity or man-made earthquakes. We always have to worry about groundwater contamination, that we do a good job of casing off those zones where we don't want our fluid flow to contaminate, where people are getting drinking water from. Our production growth has often exceeded our ability to have pipelines that will take the crude oil and particularly the natural gas to a refinery or to an export terminal for markets. And then, again, when we get ahead of ourselves and we're producing gas and we have no way of moving it, there's in some basins there's been an increase in gas flaring. Well, here's just two slides where we're using our data analytics, and I think it's telling us a very important story. And there's this paper, this analysis was done by Schlumberger. Then you have the SPE paper there, a number there that you can go find the paper and read it. I'd recommend that. It's a very interesting, kind of example of a lot of data. And here, shows your typical type curve for an unconventional reservoir that I showed before, essentially as production against days, or in this case, months on production. And it can see, when we graph it this way, we can see that we've year upon year upon year, we're dramatically improving the initial production out of these wells, which is a good thing. We're getting more oil. We're getting our money back quicker for time value of money. If you're putting your economist hat on, that's a good thing. But we haven't really substantially changed that very rapid decline curve. So we need to worry about that, because more than about a year into the life of this well, we're having to deal with this part of this curve where we're on artificial lift, and we really have to be very careful about making sure the well operations continues to be profitable. But this next slide plots the same data, but it normalizes it. And normalization often is a very important statistical technique to allow us to compare different things in different kinds of ways. So here, the analysts and the authors of this paper essentially created a normalization parameter called proppant per lateral length. And this is taking into advantage, into account, how long of the lateral wells are being drilled in order to get this greater production. The amount of proppant and kind of is a way to also talking about the energy and number of stages that we're trying to use. So with this normalization parameter against production, we get a pretty surprising result. And we're trying to look at effectiveness and efficiency, not just volume growth. We're finding out that year after year after year, we're actually getting less efficient. And that's mostly because the amount of energy that we put into the ground through the lateral length, the proppant, the stages, the water use is essentially on a normalized basis, not producing more oil, more profitable oil. It's producing more oil, as the previous slide showed, but the profitability of what we're getting back is decreased because of the cost, the investment in the effort that we have in order to try to recover those higher volumes. Well, that kind of shows the power of analytics. We're drilling lots of wells. We have lots of data. So the availability of these analytics are becoming easier to get our hands on and to try to work with. But we also have to think about kind of the third dimension in terms of we really are drilling up a cube of rock. And the fourth dimension in the fact of time where, how efficient are we at recovering, all the oil that we can for over time. So we've gone from 2 dimensions to 3 dimensions to 4 dimensions in terms of our challenge, in terms of trying to really manage the shale reservoir, making the problem that much more complex. Well, again, traditional well pad development kind of looked at everything just in terms of the 2 dimensions of essentially the rock, the vertical and the horizontal within the wellbore. Going to a cube development mindset, which many operators now are, and then we can, our drilling capability is there. This is not a challenge that we can't master. But when we begin to take a look at the completions technology, when we put wells close together, we have to worry about that the fracking of one well might really significantly impact the pressure regime in the next door neighbor well, often called parent wells, and then child wells for the secondary, wells that are drilled close together on a pad. And looking at all of this 3 dimensions, 4 dimensions, with the economics that I talked about, that's where the challenge of shale is right now. In order to we've got lots of data, but we have to really keep our eye on the fact that we have to produce profitable barrels of oil and volumes of natural gas, and not just the higher numbers that we're trying to get a hold of. Well, I said that, there's other sorts of challenges, and in some analysts really talk about these things as our bigger challenges yet, rather than the operational or the economic ones. And those have to do with data. How well can we manage all of that, the data that we are collecting? And earlier before in my myths and truths, I was talking about how difficult it is to really manage this volume, velocity, and variety of data that we're recording. And then the real idea is we want to take this data and not just get more efficient in a single discipline sort of view. We really want to try to, with all of this data, change the way we do business, almost create a new digital culture. And, when we look at that, a lot of it seems exciting to me when you first hear about it. It said, well, sure, I want to work better and faster. And it's exciting to me to use these new technologies in order to try to improve my problems. But when the direction sort of changes, and maybe senior management comes in and said, we will change and we will do it this different way. Well, maybe I don't like that so much. Maybe the technology application suite comes in and says, you have to change the way you've always been working to operate according to this new software. Well, maybe I'm not so excited about that change. So this gets back to the point I mentioned before. Transformation is more than just the technology. The impact of the technology change, the cloud, the big data analytics, artificial intelligence, Internet of Things, et cetera, is kind of the tip of the iceberg. And it may be the exciting part of the story when we try to look at it. But the impact of enterprise change is much more significant. Does our business model and strategy fit digital transformation? Do we have the competencies, the culture, the mindset to change the way that we work? Can we kind of speed up the corporate clock speed and way we make decisions and have governance? Is our IT, role, does it have to change? Often it very much has to. How are we getting the message from senior leadership and the investment in change management and in new skill sets? And how is our kind of downstream customer ready to work with us and our oil field service partners, our joint venture partners, our government regulators, et cetera? Are we all ready to kind of cooperate and work in a different kind of way? Do we have the incentives, the prioritization to do that? Because it does involve an awful lot of change. Well, we're talking a lot about automation. We're talking a lot about how all this technology works together, but the human being has to fit into the picture too. And here is a very good, kind of a model from a good research organization called LNS Research out of Boston, Massachusetts, in the United States, that really focuses on the operational technology side of all of this. And in that, we are not removing the human from the picture. The human's role changes, often significantly, but we have to connect the human back into all of this other technology. And so, how do we do that? With their smart devices, with their, virtual reality glasses, with the safety sort of information and that they need and when to know what information and what alarms and what alerts that they need to respond to and how they need to do that. And in this, essentially, everyone becomes an analyst. Everyone is connected. Everyone has a lot more information, and the velocity of that information is greatly speeded up. So how does the human comfortably fit into all of this? That's one of the challenges that we have for each and every one of us. Well, the digital core, or the digital platform, or in this case, I talked about the industrial Internet of Things digital core. It really is a combination of a lot of different advances in a lot of different major parts of our business. The back office, financial, HR, procurement, legal systems are often come in the advances in our ERP systems. Information technology changing, high performance computing, GPU chips, in a lot of different ways, really enable our ability to do those remote decision support centers. Cloud computing is an example in all of that. Well, oilfield service companies come in. They largely have developed our application suites for our understanding of the subsurface. They have a major role to play in bringing our understanding of the reservoir to the core. And then we have operation technology, such as the control systems and the sensors and all of this AI for the artificial lift and the drilling sort of operations have a role to play. And even one that maybe you wouldn't think of or add to this mix, but engineering technologies. We now design and construct an awful lot of our new facilities first in a mathematical model through CAD/CAM sort of technologies. But in that is growing up, and it is getting more robust and more precise and carrying more information. So it's now really creating the digital twin that we've talked about we need for this digital core. So integrating all of these different inputs and influences, they're all important. But how do you put these together in an integrated kind of way? Well, we're coming near the end of the challenges that we're trying to talk about, and I have to talk about cybersecurity. The good news is we are connected to the oil field, even in remote locations. The bad news is we are connected, and there are some open back doors and different ways that hackers and other malware sort of things can contaminate and disrupt and really do some terrible things to our operations. Not just stealing of data, which may be one layer that we're talking about, but actually gaining control of oilfield service equipments and causing them to malfunction. So with all of this stuff that we're building, all this connectivity, we also have to make sure that it's secure. And, the bad guys, unfortunately, oil and gas is one of the top 5, kind of industries that the hackers are targeting. So we're not immune. We're not invisible. We are a target of a lot of this stuff. Sometimes outsiders, malicious efforts, and sometimes even insiders that are either intentionally or unintentionally doing the wrong things. Well, I'm going to come to a summary, a conclusion here to what all this digital transformation, this digital oil field 2.0 really means. And we have to really talk about, keeping our eyes on the prize. And again, the prize is a business prize, not just more volumes, but more profitability, not just more wells drilled, but more efficient and effective wells drilled. So are we really trying to improve incrementally one of our different functions, or is there an opportunity to accelerate the entire enterprise? When we look at the business plan, it is profitability over just volume growth. It is operational excellence, which really means efficiency and effectiveness. We have to always keep our eye on the high priorities of safety and health, but then the economics, the cost, the operating expense, the environmental footprint of our operations, and our ability to work with local communities and get the license to operate, not just from regulators, but from the people that are living next to us. And reduce, obviously, drilling and completion costs as well as the production costs. The unconventional reservoirs and effectiveness, many companies have been talking about very significant production increases in a short period of time without adding a lot of staff. The doing more for less, sort of mantra that we began this whole lecture about. And we really need to look at the ultimate recovery, not just that short IP growth that we're talking about. And it's a whole system. It includes the midstream. It includes the natural gas part of the reservoir, chain as well. So there's a lot to think about. But a lot of technology are very interesting enablers for a lot of this change. But don't let the technology just be the distraction. Keep your eye on that economic prize. Well, to conclude, what does the future hold? It's kind of interesting, to kind of speculate and think about what the future digital oil field might look like. I'm going to leave you with a quote here from my favorite science fiction author, William Gibson. And his quote was, "The future is already here. It's just not evenly distributed." You can go to some oil fields today, like that remotely controlled Valemon field from in Norway, and you can begin to see parts of the future that are already here. But you can also go to many other operations in other places where really the reality hasn't really grown much from the 1970s or even earlier from that. So maybe the future, we can recognize it by seeing some of the things that are already here. We just have to build the integrated view. We have to build the enterprise view. And we have to prepare ourselves and our organizational cultures to be ready for the transformation. Thank you very much.